Okay, so now we will discuss some important theories. It is called the control volume. Let's say this is control volume and control surface. Okay, so we'll try to understand this at first and then we will start with some other theories. So from thermodynamics, actually, throughout the semester, control volume, we can define it as CV and this is as CS. You will see most of the time we will write it as CVCS. Anyway, so in thermodynamics, actually we know the definition of the system. So we have different systems. We know the open system, we know the closed system, and we know the isolated system. So that's two different systems. So far we discussed the closed system, the open system. The difference between the closed and the open system is, the enclosed system, and we can expect only the energy interactions between the system and the surroundings, no mass interaction. Where in the open system, we can expect both mass and energy interaction, right? So today we are going to discuss a air compressor as an example, because air compressor is an open system. So this week we are doing the air compressor experiment. So let's draw this on it first and then I will slowly explain actually. So let's say this is the air compressor. This is the air compressor, right? We have, let's say this is the inlet, this is the outlet. So what we said, this is an open system. In here, actually, we usually run the air compressor by using a motor. So let's say we have a motor here. Okay, so we have a motor here, we connected with the motor. So what will happen, the function of air compressor is it can compress the air, that means the low pressure air to high pressure air, right? So what we can say, the mass, it will enter into this air compressor through this way. So this is the mass in, okay, and the mass, this is mass out, okay. And importantly, we said the mass, it will be in the low pressure during this in, and it will be high pressure here when it will out. That means once the air compressor compress the air, the pressure will rise, it will be high pressure in this case. So motor, actually, we will run this system by using the motor, and we will get, this motor will supply some mechanical, it will supply some mechanical work. So we will get work, the system will get the mechanical work from the surroundings, right? During this operation, this air compressor will be heated, and based on the temperature difference, it can transfer some heat to the surroundings. So it can transfer the energy, okay, it can transfer energy, you can say heat transfer to the surroundings. So that means here two different things. You can say the mass interaction is happening and the energy interaction is happening. So you can say this is open system. If we want to analyze the open system like this air compressor or turbine engines, so if we want to analyze these types of open system, especially there are a lot of engineering applications that we need to use this concept. So if we want to analyze this system, then what we can do, we can consider a control volume. We can consider a control volume. So if we draw a dotted line, and if we enclose this system like this, let's say if we draw this dotted line like this, so inside this dotted line, the volume inside this dotted line, we can say this is actually the control volume. So this is actually the control volume, and this dotted line, the surface of this dotted line, this is called the control surface. We said then this is actually CV, control volume, and this dotted line, the surface, it is CS. So control volume, actually we need only where the mass interaction is happening between the system and surroundings. So that's most important. So we'll discuss a bit more during the lecture. So what I said here, you need to keep in mind, guys, when we're just putting this system um, by this dotted line, the volume inside this system, we say it is control volume. This is for some definite area, you can say. And the surface of this dotted line, or the surface of this control volume, we can say this is control surface. So I think that's it, and we will discuss a bit more during the lecture.